Okay, so this video is going to talk to us about a couple of different constructions that have been on the Common Core geometry exams. So the first one says to use a compass and a straight edge to construct an inscribed square in circle T as shown below. So this came right from a Common Core exam. They already gave you circle T with the center T labeled. So your first step in constructing a square inscribed in the circle is to construct the diameter, or draw in the diameter AB. Remember that diameters go from one side through the center to the other side. So I'm just going to draw a straight line connecting one side to the other side through point T. And I'm going to label this as AB. From there, I need 2 more points to make a square. I already have 1, 2, and I need 3, 4. So to get 3 and 4, say C and D, I'm going to construct the perpendicular bisector of AB. So we do this by putting our center on A, opening the radius up more than halfway, meaning more than T. And I'm going to swing an arc above and swing an arc below. Then I'm going to switch and keep the center on B now, and the radius should stay the same. You should not be adjusting your compass whatsoever. Looks like I just got to move my clipboard a little bit. Okay, so you can see that I didn't quite intersect up here, so I'm just going to put my center back on A. And I'm going to swing that same arc again. Now I have 2 points of intersection with my arcs, and I'm going to draw the perpendicular bisector going straight through them. Now instead of choosing points not in the circle, I want to choose the intersection point of my bisector and my circle. Say point C, and down here, point D. Now when I connect A, B, C, and D, I will have the square inscribed in the circle. So again, now I'm just connecting A, B, C, D. And there's our square inscribed in the circle. The next construction asks you to inscribe a hexagon in circle T. So again, they give you the hexagon, they give you the circle with T. The important part here is that we first measure from the center to the edge of the circle, meaning find the length of the radius. Otherwise, if we just start swinging arcs of any length, then we are not going to get a hexagon. Second step is to put some point on your circle. It doesn't matter what you call it. You don't even have to call it anything. I'm just going to call it P so that we can refer back to it. So now, using that same length of the radius that I used originally measuring the circle, I'm going to put my center on P and swing a baby arc on the edge of my circle. Then I'm going to pick up my compass and I'm going to do the same thing. Swing a baby arc with the center on that new intersection point. And I'm going to keep going all the way around my circle. Center on the new intersection point, swing a baby arc. Pick it up, center on the new intersection point, swing a baby arc. Okay, so I'm going to keep going. I should have 6 total arcs, with the last one passing through P. Perfect. So now my last step is to construct that hexagon, meaning connect all 6 points. From P to this point over here. If you want to make actual points on your intersections, you're welcome to do so, and then connect all of them, that's fine. I'm sorry, my paper is a little turned and cockeyed here, it just makes it easier for me to connect them. And I suggest that you turn your paper however it's helpful to you in order to make these constructions easier. Because sometimes your arms get a little crossed and mixed up and it's goofy looking. But if you turn your paper, then you're going to be more successful. So here's our hexagon inscribed in circle T. Now the next one is very similar, except this time we are doing an equilateral triangle inscribed in circle T. So you can see that the steps here say they start the same as a hexagon, but instead of connecting all 6 of them, we're going to connect every other point. So again, I'm going to just measure from the center to the outside, make sure it's the same. Perfect. So now I'm going to put a point P here. Swing an arc. And again, I'm just going to turn my paper because it makes it a lot easier if I can turn the paper, then my arms don't get awkward and crossed. I'm just going to continue going all the way around the circle. Remember, we need 6 total arcs, with the last one landing on your original point. Alright, so now my last step here is to connect every other point, or every other point of intersection, rather. So here's one, skip one, plot a point, skip one, plot a point, and now I can connect to make an equilateral triangle. And again, the important part here is that you remember to measure from the center to the outside of your circle, because if you don't find that original radius and you just start putting arcs around your circle, then you are not going to get consistent arcs all the way around that are the same length to give you 6 of them in total. Number 4 says to divide segment DE into 4 congruent segments. So I just kind of want to sketch out what this would look like in the end. We have segment DE, and we want it to be cut into 4 congruent segments. So 1, 2, 3, and 4, which means I need this first original midpoint, say M. Then from there I'm going to make midpoints F and G, because then I have 1, 2, 3, 4 congruent segments. So in order to create midpoint M, I'm going to first do the perpendicular bisector of DE. So I'm going to start by putting my center on D, radius opened up to more than halfway. You can clearly see that my radius point is more than half of DE. I'm going to swing above and swing below. Then I'm going to switch, put it on E, keep the radius the same. Swing above and swing down below. I'm going to connect straight through, and I'm going to label this midpoint as M. You can really call it whatever you want it to be. I just like M for midpoint. Now from here I need to create another midpoint F. So I'm going to do the perpendicular bisector of DM and then also EM. So first DM, I'm going to close up my radius so that I'm just more than halfway of DM, and swing the arc above and below. It's helpful if you have nothing underneath your paper when you're doing this, because otherwise your compass gets stuck. As you can see with my clipboard, the top part here, my compass keeps hitting into that. So if you have nothing underneath your paper, it makes life a lot easier. So now I have DF and FM. Now again, I'm going to construct the perpendicular bisector again over here, but this time of M and E. I can actually keep the radius the same as what I just previously used, because the same length of DM is the length of EM, because remember M was a midpoint. If you want to adjust your radius, that's fine. Just make sure that you're more than halfway of of M and E. So it's the same construction 3 times over, creating midpoints every single time to allow us to create 4 congruent segments. We can see that we have DF, FM, MG, and GE. 4 congruent segments, just like the question asked. The next construction that we have here asks us to create or to construct a mid-segment DE such that DE is parallel to AC. So if we sketch this out to see what this would look like in the end, AC is hanging out along this left-hand side with B way over here. And if we want AC and DE to be parallel, then that means we need midpoints D and E, because after all, a mid-segment connects midpoints together. So again, we're doing that same construction that we just did in number 4, where we're creating midpoints of 2 different line segments. So center on C, radius more than halfway, swing above, swing below. Now this one might get a little messy. Your arcs are going to cross each other, especially once you start the second midpoint. It's helpful to use different colors if you have different colors. So here I'm just going to connect, but really, what I really want to focus on is creating this midpoint, E. Then I'm going to do the same type of thing. I'll switch colors so you can see what I mean about how it makes it easier to construct the midpoint of AB. So again, center over halfway, swing an arc above and below, switch, swing above and below, connect, and now because I use different colors I can focus solely on the green. I'm looking for the green matching, or crossing rather, segment AB. So here I get midpoint D, and now my last step is to just connect them. Segment DE is in fact the mid segment of triangle ABC. Number 6 says to construct triangle DEF that is formed out of the mid-segments of triangle GAP. So what we're going to do is the same thing that we just did up above, except we're going to construct this mid-segment, this one, and this one to make a triangle, and it'll end up being triangle DEF. So we need 3 entire total complete mid-segments, which means we need 3 midpoints. So again, using different colors will make your life easier here. I'm going to start by constructing the midpoint of PA. So center on P, radius opened up, swing above and swing below. Switch to A, keep the radius the same, swing above and swing below. Connect. And again, the thing that we want to focus on here is the midpoint. So I'm going to choose to call this D because after all we're making triangle DEF. I'm going to switch colors, and now I'm going to do my midpoint of PG. If you want to pause the video and fast forward because you got this and you can do it on your own, you don't need me talking through it, that's fine. Just make sure you check in to see if you did it correctly afterwards. So center on G, swing above, swing below. Now I'm focused on blue, connect blue arcs together, and where blue meets PG I'm going to make point E. And one more midpoint to construct here, midpoint of GA. So center on G, close up the radius. This time I'm using pink. Okay, so now I've got my arcs intersecting, and I'm going to cross through them with that perpendicular bisector to make point F. Now remember, it says to construct the triangle DEF, so we actually do have to connect these 3 points, D, E, and F. When I taught this, I saw a lot of my students actually shading in the triangle when they were finished with it because it helped them to see where that medial triangle is. By the way, that is called a medial triangle. It's just formed out of those 3 mid-segments. Our next construction is, it seems like there's a lot of steps and it's a lengthy construction, but it's actually not so bad. All we're doing is constructing a triangle on the line below, right here, that's congruent to triangle XYZ. This was on the last Common Core exam in January of 2016, so I think it is an important one to talk about. But all we're going to be doing is copying segments. So we're going to do this construction by using the triangular congruence theorem, side, side, side congruence. Because, again, we're copying segments, they're going to be congruent to one another. So our first step in copying is to create a point down here at the very bottom. They want us to make triangle ABC congruent to triangle XYZ, which means that A is going to match up with X. So this first point will eventually match up with X, which means that this will be called A. My second step is to put my center on X and my radius on Y. And I have to show that I'm actually measuring this, so I'm going to swing just that little baby arc and pick it up. Then I'm going to put my center on A, down here at the very bottom, and swing that baby arc, pick it up. Now because B matches with Y, this point that we just made of intersection is now going to be called B. So we already have one segment that's congruent. That's the first part of the S's. Now my second step is to put my center on Y. Open up my compass so that it hits Z. And we're going to swing that baby arc. I'm sorry about my stars. I got a little bored one day. Swing that baby arc to show that we've measured. Now I'm going to pick up my compass, put it down here on B. Because I was on Y, I now need to put my compass on B. And I'm going to swing this arc. I'm going to swing it kind of large because I need to cross it with another arc, and I don't know exactly where they're going to cross. So I'm just going to make it kind of large so that eventually once I measure XZ, I'll have another arc that crosses it. So that's our next step, to put our center on X and our radius on Z. Remember again, you cannot just simply put them here. You actually have to draw the mark, the arc, to show that you've measured. So because I just had my center on X and X matches with A, I'm going to bring my compass down to X. And I'm going to swing a little arc to cross over the other one I already had there. This point of intersection will now match up with Z. And again, based on our congruence statement up here, C matches with Z. So that means C is our last point on this triangle. And then the last step is to actually connect them. A and B are technically already connected, so you don't have to connect them again, but you do have to connect A and B to both of them to point C. So now again, XY is congruent to AB, BC is congruent to YZ, and XZ is congruent to AC. You do not have to put these congruence marks on there, but it just justifies why we're proving that these triangles are congruent by side, side, side. Number 8 is our last construction for these notes here. It says, given the line below, construct a 30-degree angle where the side of the angle is equivalent or equal to the length of AB. So what we're going to do is first create a point, say, I don't know, P, on our line. Because what we're going to do is eventually create a 30-degree angle. And to get that 30-degree angle, we need an equilateral triangle. And to get that equilateral triangle, the sides need to be the length of AB. So I'm going to measure AB just like we had done up on the previous example. Center on A, radius on B, close it up. And swing that little arc to show that we've measured. Now I'm going to put my center on P. And to make this equilateral triangle, I'm going to dip a little bit down below the line and swing way up above. Dip a little down, swing way up above. Now I'm going to call this, say, Q. They did not specify what letters they should be, so you can call them whatever you want. I'm going to put my center on Q, keep the radius the same because remember we are making an equilateral triangle. Dip a little bit below and way above. And I'll call this point S. So now I'm going to just connect these to make a triangle, where each side is equivalent to the length of AB. The next step is to create that 30-degree angle. And in an equilateral triangle, we know that the angles are already 60 degrees, because 180 divided by 3 angles is 60. So angle P, for example, is 60 degrees, but I have to somehow get it into a 30-degree angle. So to go from 60 to 30, I'm going to cut it in half, meaning I'm constructing the angle bisector. You could construct this of any angle, it doesn't matter which one. I'm just choosing to do point P because it was the first point that I made. So to do this, we're going to swing 3 different arcs in total, starting with our center on P. And I just closed up my radius, as you saw, just a little bit, so that I'm going to make a smiley arc to go across side PQ and PS. Again, the small smiley arc. Once I have these 2 points of intersection with the triangle, here and here, I'm going to put my center on one of them and swing a little baby arc out here. Then I'm going to switch and keep the radius the same, swing that baby arc. You can see that from this original arc, I did not change the radius whatsoever. It's easiest if you keep the radius the same, that way you don't have to remember if you adjusted it or not. And then the last step is to construct that line, the angle bisector going through, from P through this point of intersection out here. So now we have our 30-degree angles here and here, because remember again we took 60 and we cut it in half. So that's it for these constructions. Again, some of these have been on the Common Core exams, other ones have not been, but I can predict that they might be at some point in our lives. Happy constructing!